We'll move on to the next topic, context-free grammars. CFG, in short form, we call it as. So this we already discussed from ATC, finite automata theory. Fine. The same kind of topic it is. What exactly context-free grammars are. The productions, terminals, non-terminals, variables, start symbol and all. Okay, regarding that we have a complete discussion. For what purpose we need to discuss the CFG under compiler design? So as I previously explained, the tokens, whatever we receive, so that will be based on a pattern exactly. Okay. Later, after receiving those tokens, we need to generate a parse tree exactly. Okay. Then how parse tree can be generated? Whether the tokens are enough? No, it is not enough. Okay. So we need to build a parse tree. Then using that parse tree only we go for the next phase of compiler exactly. So for building this parse tree under syntax analyzer, okay, we need context-free grammar over there. Fine. Okay, we are depending on some production. Okay, we need to prove that the received input, whether it is going to be satisfying the exact syntax or what. Okay, regarding that we need to check by using a parse tree. Then we can go for the next phase exactly. Okay, so next, for the formal definition of a context-free grammar CFG, we have a context-free grammar. Okay, grammar for short. Okay, so wherever we are using CFG, we are just using it as a grammar. Okay, consists of terminals, non-terminals, a start symbol and productions. Okay, so these are the few components which we have for CFG exactly. Then grammar will be equal to V, T, P, S we call. Okay, where G is grammar, okay, T is terminal, V will be non-terminal, also we can call it as variable. Then S means the start symbol and P means productions exactly. Okay, so grammar consists of total 4 components. First one variable or else non-terminal, then T stand for terminal, P stand for production and S stand for start symbol exactly. So here we got one example for a context-free grammar. Okay, just observe. E derives E plus T or else only T. Fine. T derives T into F or F. Then at last F derives ID exactly. Fine. So here we got total 3 different productions available over here. Okay, we don't have a sample string. Okay, what it is going to generate. Okay, now we'll just categorize. Okay, which should be called as a terminal and which are called as a non-terminal, which should be called as a start symbol exactly. Okay, so when it comes for the terminals, fine, these are the very important components, okay, of context-free grammar or any particular grammar exactly. So this we can consider it as an alphabet, okay, using which we can generate this string exactly. Okay, for preparing this string or for generating a string, okay, we need some alphabets exactly. Okay, so here terminals we can consider it as an alphabet. Okay, so using this terminal, whatever the sentence we are generating means the complete a set of string or else a group of string. Okay, we are considering it as what? Non-terminal exactly. Okay, so under that whatever the set of components we have, or set of strings we have, okay, that will be considered as a non-terminal or variable. Okay, the individual components which we need to generate this string, okay, that we are considering it as terminal exactly. Okay, so here the term token name we are considering it as a terminal exactly. Frequently we are using a name called as a token. Okay, so that is nothing but terminal exactly. So whatever the tokens you are going to get, that should be considered as a terminal exactly. Clear? From lexical analyzer, source program to token conversion will be done. Token will be submitted for the parser or else like a syntax analyzer. So syntax analyzer should consider those token as terminals exactly. Clear? Okay, so in the above grammar, okay, terminals are plus, star and ID. Okay, those who are in lower case, maximum, that we are considering it as terminals exactly. Okay, those who are in upper case, that will be considered as non-terminal exactly. Okay, then when it comes for non-terminals, non-terminals are the syntactic variables that denote set of strings exactly. Okay, the group of tokens or group of terminals we are considering it as non-terminal exactly. Okay, then here in this example capital E, capital T and F are non-terminal in the above grammar exactly. Okay, the set of string denoted by non-terminal help defining the language generated by the grammar exactly. Okay, then later start symbol. Okay, so this is sometimes in your production, okay, there will be mentioned like S will be the start symbol. Okay, if you don't have any kind of representation like which should be considered as a start, okay, here out of these three production, okay, the first production what we have in that left hand side of the arrow mark, okay, left hand side of the arrow mark capital E you have, in right hand also you have capital E, but don't consider right hand side. Left hand side of the production, first production what we have, that should be considered as head. Clear? Okay, so